All right, so we're going on to part two of looking at our surveys, charts, graphs, and tables. In the first part, we talked about data, validity, bias a little bit, and just kind of introduced to the idea of making sure that our results actually mean something and that they're valid. So now I'm going to go on to part two, and we're actually going to talk about presenting our data. There's lots of different ways to present the data once we have it, and it's important that we do it in a way that is accurate and meaningful. Okay, the first way that we can present data is in a chart or a table. Tables are really good, or charts are really good for showing a lot of data in a small area, right? To be honest, it can be shown at once, all at once, a whole bunch of different things, but really it's not as visual. It's not as quick or as easy to read as a graph, but you can have a whole bunch of stuff there at once. Okay, again, good for comparing several categories or groups at once. Let me show you a couple of examples. Okay, here's a table that's talking about different people, different students and their parents. This is actually a little bit with psychology, comparing negative things that are said, comparing emotions to other mental states. You can tell that if I had a graph for every single one of these, that would be a lot of graphs. Okay, so it's nice to have one table that kind of puts everything together in this situation. Okay, another example right here. This is dealing with fashions, right? A type of fashion, whether it's modern, simple, or playful. And you know, again, with this many items, that many graphs could get quite complex. And so it's nice to just kind of have all the data in front of you. You can look down, find the bigger numbers, the smaller numbers, the central numbers really easily. Again, but you have to be careful making sure that the data is correct. Let's look at bar graphs. That's another very common form of way to present data. Bar graphs are used to compare quantities of different categories or types. Okay, now one thing is that on bar graphs you can double up, things can overlap. Okay, here's one example of a bar graph that has M&Ms. Now obviously an M&M has to be in one of these categories. It can't be both blue and green. But this will appropriately show quantities of a specific category. Okay, and so it's very easy to see how that's being used. Here's another example. Blankets that my friends have. Some friends have a plain blanket, some have electric blankets, some have quilts, some have two thin blankets. The thing with this is that maybe one of my friends is in more than one category. He might have an electric blanket and a quilt, or he might have a plain blanket, like a thick one over the, or a quilt, I guess, over the top, and then two thin blankets below that. And so just by taking this, you couldn't say that there's 8 plus 6, 14, 24, 25. You couldn't just say that there's 25 people being surveyed there. There could be less than that, and one person could be in more than one category. And so that, in some ways, is one of the nice things about bar graphs, is that you can have one person or one observation fit in more than one category. All right. Here's another example of a bar graph that was definitely a fail. This is from a news station, and you'll notice that the 11% is higher than the 11.9%. Oops. Not only that, but all of these 11.5, 11.7, 11.9 are all greater than 10.5. Yes, that is a fail. Anyway, on to pie charts. Now, pie charts are really good for comparing the parts of a whole, right? You can kind of use bar charts for that as well, because the bar charts will separate it into categories. But if you really want to see everything being compared together and what percentage of the whole it is, pie charts by and far are the best. With a pie chart, all the individual pieces should add up to 100%. Now, one of the results of this is that no overlap can occur, right? In the last one with the blankets, I could have a friend that had a blanket and a quilt, and that was okay. You could put those into those separate categories. But with a pie chart, you can't do that, because then those sections are overlapping. And it has to be definite pieces so that they add up to the total number of people with blankets, or the total percentage. All right, so let's look at a couple of things where I got a pie chart. So here's one for time spent eating an orange. All right, so you spend this much time, that looks like about 60% of the time, peeling the skin off. Yep, and then when you get the skin off, you start picking off all those itty bitty white stringy bits because those are just annoying, or you really think that they're more bitter. So there's your another little, 40 or 35%. And then you actually get to eat the orange, and that takes you about 2 minutes compared to the 20 minutes that it took you to prepare the whole thing. So this again is showing percentages. None of these times will overlap. You take the skin off, then you do the white stuff, and then you do the eating. You probably don't do more than one of those things at the same time. And so no overlapping, it's parts of the whole. Here's another example. This is not my husband, but this was found online at Graph Jam. What my husband does with the stud finder I gave him for Christmas. Now the real purpose of a stud finder is you scan it over the wall and it'll find where you have the studs, the thick vertical boards behind the wall, because that's where you can nail nails in or screws, and you can put things up on the board, up on your wall, and so you use it to find that. But apparently this woman's husband uses the stud finder for that about I don't know, 7% of the time, and the rest of the time he holds it against his chest and snickers when it beeps. So anyway, that's another, percentage of the time either this is happening or this is happening. You can't overlap, but both of those together will add up to 100% of the time the stud finder is being used. All right, so let's look at line graphs now. Okay, a line graph generally represents data that's changing over time, but it doesn't have to be time. It can also relate some other independent variable that causes a change in a second dependent variable. Okay, so it's usually one thing that is causing a change in or affecting another. All right, so let's go ahead and look at it. I think this is a pretty good example. I don't feel this way about Monopoly. I love Monopoly, but a lot of people feel this way. At 0 hours playing with Monopoly, everybody's excited. I want to be the car. I want to be the dog. I get the battleship, right? You got all the new pieces nowadays. And then as time progresses, your enthusiasm slowly decreases until you finally get to kill me now. Yes, so this is comparing something as time is changing. All right, here's another example. When you're learning about something, right at the beginning, you're kind of not very sure with it. As the end of the term approaches, you still feel like that. You're getting close to the exam. You're studying hard. You're preparing. Yep, I think I'm getting this. I'm getting this. I memorize it every single moment. I'm thinking about it. And then the day that the exam happens, you don't remember anything else ever again. So, again, the knowledge or how much you understand or know is progressing over time. So another line graph. Here's another one, size of bug versus its location. If it's at a forest in Denmark, it's very small. If it's on your front porch, it's probably pretty big. But if it's in the shower, it's probably this huge bug that makes you scream and faint. So, yeah, there you go. Line graphs are comparing not necessarily time, but as something gets bigger or progresses, something else is changing. All right? So, in summary, this is summarizing both of the last videos. In the first one, we looked at validity of data and the bias, the questions that are being asked, or the people being asked, or the way that you represent the table can affect the outcome of our data. Okay, different graphs are good for different uses, right? A bar graph is good for comparing things in different categories. A pie graph is good for showing parts of a whole that are not overlapping. A line graph is good for showing things that change as a result of something else or that change as a result of time. Charts and tables are very good for showing copious amounts, large amounts of data. Last of all, a graph or table used for the wrong purpose can be misleading, as we again saw in that first video. So I hope this gives you a good summary of data acquisition. This by no means is everything that you need to know about making a survey and thinking about it and considering bias, but hopefully it opens your mind a little bit to gathering data, presenting it, and then analyzing someone else's data when you're presented with this so that you don't get fooled when you read the newspaper. So, hope that was helpful, and I'll see you in class.